Hi, I'm Nezvers and I do stuff. This time I want to continue with procedural animation and algorithms. Inverse kinematics, to be exact. Robotics heavily rely on it and it has important role in game development, mainly for animations. There are a lot of approaches for inverse kinematics, but one of them is super popular and easy to understand. This algorithm is called forward and backward reaching inverse kinematics, abbreviated as FABRIK. It is so popular that even Godot engine, Bone Animations, uses this algorithm. I rewrote example project for which I have preview on this channel for a while. For now only FABRIK part, but the rest is coming. If you have requests for other procedural animations, please leave them in comment section. But before we start, sip of coffee. Inverse kinematics is here to solve a problem. Like for example, you have a robot arm that is fixed to its body or somewhere else, and it needs to interact with the environment or other objects using its limbs. But how do you find angles or positions of the limb? Well, Mrs. with 4Z has already a video showing how to make a spider with its legs having like 3 segments and using math formulas, and it's pretty awesome. But FABRIK can work with pretty much unlimited amount of segments. Let's take a look how it works. Let's position our initial segments. They will be pinned like here, and 1, 2, 3, 4, and pretend they are length of 2. So total length would be 8. But in inverse kinematics, first check is to check if this total length is smaller than distance to our end goal. In this situation it could be 12, and that means we don't need to do any inverse kinematics, but just point our segments to the direction of that end goal in a straight line, and that's it. But that's not that simple in actual situation when we need the interaction. So let's put our end position somewhere in the reach, somewhere like there. Let's put the end position somewhere in the reach so we can see how we can do FABRIK approach. Let's put it here. We start with backwards reach, so we are putting this point here. We get a direction to previous point, use the length of this segment, and from end point it's somewhere there. We find direction to previous point, use length of this and position point here. Find direction to previous point, use this length, and continue the same for this point. And the situation is that we are starting offset from the position we supposedly are pinned. But no, we can do a forward reach. Next we do exactly the same, only in forward direction, but using data from backwards reach. So we position there. This point is now back again on pinned position. We find direction to the next point, use the length. It's nope, somewhere here. We find this direction, use the length, position there. Then we find this direction, use the length of the segment. We put there, so we draw a line to the endpoint and draw here. Look, we are much closer to the needed endpoint than we started. And FABRIK is iterative process. We need to have our endpoint to be at least at distance of 0.1 to be considering this FABRIK complete. Here is an example project I made for this video with a neat tentacle that's trying to reach the mouse, and you can reposition its pinned segment. These are all needed variables, and pin pose is a variable where I'm pinning the tentacle origin point, and pose is positioned at mouse location. Error margin is the value of needed distance from the tail end to the end position. To consider FABRIK inverse kinematics successful. Length is the length of each segment count, how many segments there are, and total segments is just multiplying them together to know total length. Position list is array of vector2 points where I'm positioning each point in this tentacle, starting from the start of tentacle to each segment's points and the tail of that tentacle. Let's start with a draw function. We choose a color, and for each point in our position list, except we use one index less because we are referencing next point too. We need a starting point for the line and ending point for the line. We draw a line from first point to the end point. Use color and how thick our line is. So next I have unhandled input for some interaction with that tentacle to position the pinpoint and for position the tentacle is trying to reach. So if event is input event mouse motion, that's our movement of the mouse, the end position is assigned to a value of mouse local position. Else if event is action pressed, mouse button left, I have defined this here, mouse button left. Our pin position is changed to get local mouse position, and also we are updating the very first point to this value. In ready function I'm assigning pin position value to get viewport rect to get active viewport. Its size is multiplied with vector2 of 0.5 and 0.9. It's because I wanted to position the pinpoint in middle of width and 0.9 of height. For each point we need 1 point more than we have segments, because I need not only the start pinned position but also a tip. So in position list I append each of these positions. I get that with having pin position value and adding up I times vector up. It's basically like that. And multiply it by length of our segments. That is allowing our tentacle to be positioned like that. In process function, because I'm not really using delta, I put the underscore, otherwise I will get some warnings. So very first thing in each frame when we are going to do FABRIK iteration, we need to get a distance from our pinned position to mouse position where the tentacle is trying to reach. And we can get that by target position minus the starting position. And we can use built-in method called length to get float value of length. And as I said before, very first thing we need to check if that distance is longer than our segment's total length can actually reach. We don't really need to do any inverse kinematics because our tentacle will always be straight. So I'm using straight reach method. It's just a direction we can get again using the target position and minus starting position. Normalized, we get a normal vector. Then for each index in our position list, size will give our count of how many indexes we have. So for each point in position list, adding to pin position I multiplied by direction multiplied by length, and that will build our position list in the direction of our end position. Otherwise, if our check returns else, then we need to calculate as the first thing the distance from tip of the tentacle to end position, if we are close enough. As before, this is target position minus starting position. We get starting position by checking the last index in position list, and we use the method length to find the length of the vector. I used this variable to know how many times we are iterating in FABRIK backwards and forward reach, because there could be a moment, like for example, how many times we get print. In normal situation you get like 3 iterations, but sometimes, as you can see right on the edge, you can get huge numbers that could slow you down and unnecessary to reach that 0.1 error distance. And because of that, I introduced this iteration variable. So we are limiting just to 10 iterations. I would suggest mainly use for loops instead of while, but I thought that while loop would be more conceptually easier to understand. So if our error distance is bigger than our chosen error margin, we need to do this loop, but don't forget to do a recalculation of error distance at the end of the loop, otherwise you will be stuck in the while loop. And increase the iteration number so we know if we are passing the iteration limit. As I said, FABRIK consists of 2 reaches, backwards and forward reach. In backward reach method, I'm using a variable last to make it a bit easier to read. Its value is the index of the very tip in the position list. I'm assigning the value to the last position to end position. I'm using for loop to iterate for each index in range of from 0 to last, excluding the value of last. To make it easier to read, I'm using variables for point 1 is value of position of the last position minus the I. Each loop it's iterating from the tip going down to the pinned position, and P2 is the position of the next point in direction of the pinned position. I'm getting direction from target position minus start position and normalized. Then assigning value to P2 as position of first point and adding direction times length. Then assign this P2 value to position list next point value. Then forward reach is pretty much the same as backward reach, except it's going through points starting from pin position to tentacle end position. If you make something interesting out of it, please let me know. And I would appreciate if I could get some life in my Discord server, because right now it's pretty empty. Also, I'm planning to show a tutorial for forward kinematics, which also is pretty interesting. In case of this IK follower, it's actually the same IK FABRIK, just only the backward reach. You could make something like snake or interesting enemy. So let's see you later.